Okay, good morning, all of you. Today we will see how to apply nodal analysis to the electrical network. Right. So I'll present my screen. So now screen is visible to all of you. Then I already discussed what is meant by nodal analysis. A nodal analysis is totally based on Kirchhoff's current law. Right, that is KCL. KCL is nothing but what? The algebraic sum of current meeting at a point is zero. Is every junction two or more branches meet regarded as a node. Is one of the node is taken as a reference node or we called as a dumped node. If in electrical network there are n nodes are available, that time we'll see or we'll find out the number of simultaneously equations to be solved by n minus 1. Okay, so now this electrical network. So how to apply the nodal analysis, that we'll see. Some steps are there to apply the nodal analysis to the electrical network. Okay, the step number one is what? Locate all possible nodes. Okay, the electrical network is given to you people. Then the step number one, you have to find out what are the possible nodes are available in electrical network. Suppose we have to mark over here the possible number of nodes present in electrical network. This that we that node we called as a P. Suppose here I consider another node, that node is M. Here I consider a node, that is Q, and here I consider again O is a reference node. Okay, so now step number one is what? Step number one is what are the different nodes are there? Node R, node R, P, Q, M, and O. These are the nodes available in present electrical network, right? So now our second step is what? Step number two. Step number two. Select one reference node. Here we have to select O, O as a reference node. O as a reference node we have selected here, right? That is step number two. Step number one, locate all possible nodes present in electrical network. Step number two, select at a reference node, right? Then third step, step number third, to identify independent nodes. To identify independent nodes. Here in this electrical network, the node voltage P and Q are known, right? Here the node voltage VA is present at node P and VB is present at node Q, right? Means node voltage, node voltage P and Q are known. P and Q are known, right? Which is a independent node present in electrical network. Only node M is an independent node. Okay, that is independent node. Okay, node only node M. The node M is independent node. Only M is independent node. That is step number third. In step number third, we have to identify independent nodes. In this electrical network, M is an independent node, but P and Q are not, right? So step number four is what? To assign a voltage variable to each independent node. You have to assign voltage to independent node. That is step number four. Step number four, assign voltage, assign voltage at this node as VM. So we have to assign voltage to independent node, that is VM. Okay, that is step number four. Step number five, to write a KCL equations for all independent node. So we have to write the KCL equations for all independent node. That is step number fifth. Step fifth is what? To write a KCL. To write KCL to independent nodes, to all independent nodes, right? So here we have to assume a current in a circuit in arbitrary direction. There is no issue to assume a current clockwise direction, incoming, outgoing. There is no problem. You have to assume a current in a circuit in any arbitrary direction. There is no issue. Means we have to assume here current in arbitrary direction. Suppose here I assume a current flowing through R1 is I1. Here current flowing through R3 is, or we have to assume a current flowing through R2 is nothing but I2, or this direction we have to assume. Okay. I2, and here the current flowing through R3 is nothing but your I. See, this is a current flowing through a circuit we have to assume in arbitrary direction. So now KCL at an independent node, that is KCL at M. KCL at M is what? KCL at M is given as I1 plus I2 is equal to I3. I1 plus I2 is equal to I3. That is equation A. So that step we have to satisfy. Okay. Write a KCL equations to all independent nodes. You see here we have to apply a KCL to independent. The step number six is what? Step number six is, so rewrite the KCL equations you have obtained in equation number fifth. That is step number fifth. In terms of node voltage. Means rewrite these KCL equations, whatever we are getting in step number fifth, that you have to write down in terms of node voltage. So, so write this current, write this current in terms of voltage Vm. Okay. Now we will find out what is I1 over here in terms of voltage, right? So I1 is nothing but what? So I1 we have to write as per the Ohm's law, I is equal to V by R. That is I1 is equal to, starting from VA, I1, we have to find out I1 here. I1 is nothing but VA minus, the current is flowing from positive to negative, means here minus, means VA minus VM and resistance is what? Resistor is R1. That is R1. That is equation number 1. Okay. Similarly, way I2 is what? I2 is equal to PB minus PM divided by your R2. That is equation number 2. And the third one is what? I3. I3 is what? I3 is nothing but your VM is no voltage is 0 divided by your R3. Means VM is not I3 is nothing but what? That is VM by R3. That is equation number 3. Means here we have to write a current in terms of voltages VM. Right? That is step number 6. Or okay. So we have to whatever value you are getting I1, I2 and I3 we have to put up in equation number 8. Means putting value of I1, I2 and I3 in equation A. Means we have to put up all the value in equation number A. So what is our equation number A? That is I1 plus I2 is equal to I3. Means we have to write I1 is nothing but your VA minus VM divided by your R1 plus VB minus VM divided by your R2 is equal to I3 is nothing but your VM by R3. That is equation number 4. Okay, that is step number 6 we have to solve. Step number 7, solve the simultaneously equations and find out the voltage variable. To solve the simultaneously equations, whatever present in equation number 4, and you have to find out the voltage variable. In this equation number 4, VA, VB, R1, R2, and R3 are known. Known this value are known. Only unknown is VM, right? Only unknown is VM. So solving the above this equation number 4, you will get VM. Solving the above equations, you will get VM. These are the 7 steps. Step number 7. These are the 7 steps to solve the nodal analysis. Okay. Are you getting this point? Yes. Is
Yes.
there any doubt?
No.
Okay, then we'll move on our example based on nodal analysis. This is examples of nodal analysis. Find the current through each resistance using nodal analysis. Okay, our aim is what here? Our aim is to find out the current flowing through each resistance by using nodal analysis. Okay, so in your exam, electrical network is given. You have to redraw whatever electrical circuit is given and you have to mark the node and as well as the current. Okay, that is step number 1 you have to do. You redraw the circuit and you mark the node as well as you mark the current in arbitrary manner. Okay, so we have to mark here the node, what are the nodes are there. So we have to assume node R here, node R. Here we have to assume node P. Here we have to assume node Q. Here we have to assume node S, and we have to assume O as a reference node here. Okay. So now we will mark the node. We will the mark the current, right? We'll mark the current. We have already marked the node here. The current flowing through a resistance in arbitrary manner. The current flowing through 5 ohm is I1, then 4 ohm is I2, then current flowing through 10 ohm resistor is I3, then 2 ohm resistance is I4, then 8 ohm resistance is I5. Okay, this current we have marked over here. Okay, node we have marked it over here as well as the current we have marked. Right, the node are what? The number of node present in electrical network is number of nodes, that is P, comma Q, R, S, and O. Okay, these are the nodes. We have to choose reference node as O. Okay, which is the independent node present in this electrical network? The R node we have already known, that is the voltage across node R is 2, and node voltage across S is known, that is 10 volt. Only two independent nodes present in the electrical network. One is a P and another is a Q. Means independent node, independent node is your P and Q. These are the two independent nodes present in electrical network, right? Means then you have to apply KCL at first independent node as per our steps. Apply KCL to independent node, independent node P. So what is KCL at node P? We have to find out what is the incoming current and outgoing current flowing through a node P. So here the KCL at node P is here I1 is equal to I2 plus I3. This is your KCL at point P that we called equation number 1. So now we apply KCL to independent node Q. What is KCL at node Q? Again, we'll see the what is the incoming current and outgoing current, that is I3 is equal to I4 plus I5. That is equation number. That is equation number 2, right? Just a bit. Just a bit. That is equation number 2. Then the step number next is what we have to assume node voltage to your independent node, that is your P and Q. Means we have to assume the node voltage, that is Vp and Vq. So now independent voltage is what? Vp and Vq. That is your two independent voltage. Yes. Now this current are expressed in terms of voltage. Now you have to express whatever current at an independent node, you have to express in terms of voltage. So now current is what? I1 is what? I1 is equal to, that is 2 minus Vp divided by your 5. Then I2 is equal to what? I2 is equal to your Vp by 4 only. Vp by 4. Okay, then your I3. I3 is what? Vp minus PQ divided by your 10. Then what is your I4? I4 is equal to VQ by 2, VQ by 2, and I5 is nothing but your VQ, that is current flowing from VQ to your S, Q to S, is your VQ divided by your 10 divided by your 8. That is your equation number 2. Yes, we have to write a current in terms of voltages. Yes, rewrite the equation number 1 in terms of voltage is given in equation number 3rd. Whatever equation number 3rd, we have to put up in equation number 1 and 2. So we have to put up the equations, that is I1 is what? I1 is now 2 minus Vp divided by your 5 is equal to Vp by 4, that is I2. I2 is equal to Vp by 4. Means we have to put up whatever equations number 3rd, we have to put up in equation number 1 first of all. Right? That is I2 is nothing but Vp by 4 here, plus your I3. I3 is nothing but what? That is Vp by Vq divided by your time. That is equation number 3rd. Sorry, equation number 4. That is equation number. Okay. So similarly in equation number 2. Similarly equation number 2, I3 value is what? That is Vp minus Vq divided by your 10 is equal to Vq by 2, that is I4, plus I5 is what? I5 is nothing but Vq by minus 10 divided by your 8. That is equation number 5. Okay, divided by your 8. That is equation number 5. Then our aim is we have to simplify the equation number 4th and 5. Then you take the LCM of 4th and 5th. and you have to simplify the equation number fourth and fifth. So we have to simplify equation fourth and fifth. So after simplification, these equations, you take the LCM and all equation number fourth and fifth, you will get that is 11 by 20 VP. I'm not solving a whole the LCM. 11 by 20 VP, 1 divided by 10 VQ is equal to 2 by 5 and and VP minus 29 by 40 VQ is equal to minus 10 by 8. After simplification, equation number fourth and fifth, you will get these equations. Now you have to solving about two equations, that is this one 11 by 20 Vp minus 1 by 10 Vq is equal to 2 by 5 and Vp minus 29 by 40 Vq is equal to minus 10 by 8. So after solving these two equations, the unknown is what? That is Vp and Vq. These are the two independent nodes. Right? After solving this, you will get Vp is equal to 1.6065 and Vq is equal to 1.87871. These are the two unknown voltage you people are getting. That is Vp and Vq. So now our aim is what? Our aim is to find out the current in each resistance. That is our aim. So, we will calculate the current flowing through each resistance. So current flowing through 5 ohm resistance is what? The current flowing through a 5 ohm resistance, then you apply directly formulas, whatever we have to calculate already, I1, I2, I3, I4, I5. The current flowing through 5 ohm resistance is the current flowing through 5 ohm resistance is I, I1 is equal to that we have already calculated 2 minus 2 minus Vp Vp divided by your 5. So that is 2 minus Vp you have already calculated. 2 minus Vp is what? That is 1.605 divided by your 5. So what is your current flowing through 5 ohm resistance? Is nothing but here maybe 0.187 ampere. 0.178 ampere. Okay, this is a current flowing through a 5 ohm resistance. Similarly, current flowing through 4 ohm resistance is what? That is Vp by 4. Means the current flowing through 4 ohm resistance is what? That is I2 Q is equal to Vp by 4. That is current flowing through a 4 ohm resistance. So what the current flowing through 4 ohm resistance? Vp already known, that is 1.065 divided by 4. Yes, you will get 0.266 ampere. Similarly, current flowing through 10 ohm resistance is what? 10 ohm resistance, that is Vp, that is I3. Vp minus Vq divided by 10. Means the current flowing through a 2 ohm resistance is you will get, that is Vp minus Vq divided by 10. You will get it, the equations. The value is minus 0.00806. That is the current flowing through a 10 ohm resistor. Similarly, current flowing through a 2 ohm resistor is what? The current flowing through 2 ohm resistance is your Vq by 2. This is the current flowing through a 2 ohm resistance, Vq by 2. Vq already known, that is 1.87 divided by 2. You will get 0.936 ampere. Okay, similarly, the current flowing through 8 ohm resistance is what? The current flowing through 8 ohm resistance is Vq by minus 10 divided by 8. That is Vq, you already know, that is 1.871 minus 10 divided by 8. Means the current flowing through 8 ohm resistance, you will get minus 1.016 ampere. Okay, this is a way to calculate the current flowing through each resistance. Okay, so I hope you clear this example. Is there any doubt in that? Is there any doubt? Rohan, Rohan Bise, Rohan, Rohana,
Yes, sir.
Rohan, is there any doubt in that?
No, sir.
Is this clear? Nodal analysis.
No, sir.
You are not clear.
Yes, sir. I am clear.
Okay, fine. Okay. Shubham, Shubham Sanap.
Yes, sir.
Shubham, Shubham, have you understood the nodal analysis? How to
Yes, sir.
apply the nodal analysis?
Yes, I've understood.
Okay,
Yes.
okay.
Yes, sir.
Yes, Sakshi. Yes, fine, fine. Sakshi, Sakshi,
Yes, sir.
understood? Sakshi.
Yes, sir.
Okay. Okay. Lakshmi,
Yes, sir.
understood, no?
Yes, sir. Yes, sir.
So we'll move on our next example, that is dependent sources. How to apply nodal analysis to dependent source. Okay, this is a circuit V1. Then you have to determine V1 by using nodal analysis. So to draw this circuit, So this particular electrical network has a mixed source, right? Two dependent sources and one is an independent source. Okay, one independent source, that is your 5 ampere, and two dependent sources. One is your voltage control voltage source, another is the your current control voltage control current source. Okay, current control voltage source we call. You have to draw this circuit. So you have to redraw again, and it marks independent nodes. You mark with the independent nodes and current in each branches. The current flowing through each branches we have to assume in arbitrary manner. Okay, so I'll mark over here the node. The first node I assume here V1. V1. Second node I have assumed here V2. Okay, so top terminal of 0.4 V1 is a control source. Okay, that is 0.41 is a control source. Is not considered as an independent node. Why? Because the node voltage or at this point is 0.4 V1 is known. That's why we have not considered this is independent node. Okay, this node is already known. Okay, this node is already known voltage, right? That is 0.4 V1 is known. That's why we are not considered as a independent node. Okay, the voltage across 5 ampere current source is given to be V1. 5 ampere current is given to the V1, which is voltage at node 1, or with respect to your, or we called as a reference node is O here. Okay, so we mark the current flowing through first is I1, here I2, here I3, okay. So we apply a KCL at node 1. KCL at node 1. What is KCL at node 1? Here, that is 5 plus your, here the current is again going to V1. So now we consider I3 here. 5 plus I3. The outgoing current is I1 from node V1. So that is equation number 1. KCL at node 1. Similarly, you apply KCL at node 2. KCL at node 2. KCL at node 2 is what? That is I2 plus, again incoming current at node V2 is 0.01 V1. That is 0.01 V1 is equal to your I3. That is equation number 2. Okay, now the current in the circuit can express in terms of voltage. Okay, as per the steps of nodal analysis, whatever the current in the circuit we can express in terms of voltage. So now I1 is equal to your V1 minus 0.4 V1 divided by your 20. I2 is equal to what? So now I2 is equal to what? Anybody tell me? I2, what is I2? I2 is nothing but 0.4 V1 minus your V2 divided by your 30, right? And I3 is nothing but your V2 minus V1 divided by your 50. Okay, now we get it here I1, I2, and I3. Because you have to put up this value in equation 1 and 2. So we have to put up this value in equation 1 and 2. So 5 plus I1, 5 plus I3 is what? That is V2 minus V1 divided by your 50 is equal to I1 is what? I1 is V1 minus 0.4 V1 divided by your 20. And I2 is what? I2 is and I2 is 0.4 V1 minus V2 divided by your 30 plus your 0. In equation number 2, 0.01 V1 is equal to I3 is what? I3 is nothing but your V2 minus V1 divided by. But we have to put up V2 minus V1 by 8. Okay, now you edit these equations. Now you simplify these equations. After simplify these equations, you take the LCM. You will get a 250 plus V2 is equal to 2.5 V1 and 1.6 V2 is equal to 1.3. So solving these equations, the voltage V1 obtained is equal to 148.1. But you will get V1 after solving. Okay, this is a steps to solve the nodal analysis. Okay, just you have to keep in mind the steps to solving the nodal analysis. Step number 1 is what? We locate all possible nodes. We select as a one reference node. Identify the independent nodes. Assign a voltage variable to each independent nodes. We write a KCL equations to all independent nodes. Or next step is what? Rewrite the KCL equations, whatever you obtained in previous, that is KCL equations. Okay, that equations you have to put up in the KCL in terms of voltage. In terms of voltage. And you solve the simultaneously. Simplifications you have to do. Okay, and here is important is what? Simplification. The steps is understood, all is understood, but major task is what? Simplification. that you have to. Very simple actually. You take the LCM. Okay. Is there any doubt in that? Okay. Is there any doubt?